The recent study shows that personalized recommendation has become an important means to improve user experience, engagement, revenue and conversion rate. With the increasing popularity of various social media and e-commerce platforms, large volumes of user behaviors data, like user transaction data, rating and review data, are being continually generated at unprecedented and ever-increasing scales. It is more realistic and practical to study recommender systems with inputs of streaming data. User-generated streaming data presents unique properties such as temporally ordered, continuous and high velocity, which poses tremendous new challenges for the once very successful recommendation techniques. Some online learning techniques based on stochastic gradient descent have been adopted or developed to support streaming recommendations. However, these models are based only on the most recent data points, and do not take into account the past observations. The models quickly forget the patterns learned in earlier stages. Recommender systems based on these online learning algorithms fail to capture users' long-term stable interests. Recently, recurrent neural model-based recommender systems are proposed, which adopt recurrent neural networks or long short-term memory to capture and store sequential patterns of interacted items or users' dynamic interests. They are often applied to the session-based recommendation scenario without user profiles. However, they also have limitations in modeling and capturing users' long-term stable interests which are hardly affected by temporal factors. To this end, we propose a novel model named Neural Memory Recommender Networks. It consists of two main components: augmented memories storing user and item information, and an controller network interacting with user activity data and reading or writing to the memories. Augmenting controller network with external memories separates the tasks of storing and processing information and makes the network only focus on processing information stored outside it. It also increases its capability of storing knowledge, therefore, users' long-term and stable preferences can persist if necessary. Moreover, the proposed model can flexibly and explicitly read from and write to the memories on demand like physical computers. The model training heavily relies on high-quality negative samples. Most existing negative sampling approaches use either random sampling or popularity-biased sampling strategies. However, the majority of negative examples they generate can be easily discriminated from observed examples, and will contribute little towards the training, because sampled items could be completely unrelated to the target user. Besides, these sampling approaches are not adaptive enough to generate adversarial negative examples. In light of this, we develop an adaptive noise sampler based on a generative adversarial network to optimize our model, which considers both the specific user and the current values of the model parameters to adaptively generate difficult and informative negative examples. We conduct extensive experiments to evaluate the performance of our proposed streaming recommender model in the streaming recommendation setting on two large-scale recommendation datasets. The results show the superiority of our proposals by comparing with the state-of-the-art streaming recommendation technique.